AlmaLinux for organizing this event. I will explain why this event is very important, that I flew up all the way to here. But let's start with the introduction. So my name is Usman. I work at Grafana Labs as a staff developer advocate, and basically I work a lot with the open source community, especially who are using Linux. I'm myself also a Linux user, but I will tell more. I work with the open source community, mostly answer their questions on community forums, GitHub. If there's any issues or bugs, try to figure out and help engineers, and also active on Slack as well, do community calls or engagement with the community, and also write a lot of technical documentation or create video content. And previously, I also have worked with Linux. I started my journey somewhere with Red Hat 6 or 7, I believe, then move a little bit to CentOS, but then it was a disaster. And now I think the path is very clear that we all need to go. I help a lot of users as well with AlmaLinux related question, and yeah. And beside work, I am a small family. Mostly my time goes in fatherhood, but also like to take some day trips with my family, or also, just doing the usual stuff. But when I have free time, I like to write something or create some content around open source software, especially if there is something with Linux. So last thing, if you want to know more about me, just scan this QR code or connect with me on LinkedIn. You can check all the stuff I'm doing for the open source. So as I explained, Grafana Labs has a very big community user group, and one thing for sure is they all love using Linux, and there is a good amount of users who are using AlmaLinux, and this platform is very good to explain like how we are working with our users and what solutions we are also providing. And today the topic which I pick is about containerization, specifically talking about Docker containers. So let's go a little bit back in the history. So back in the time, we usually have a very simple setup, like there is one server and couple of or more than one devices are using your server, and you have a very basic infrastructure and everything looks cool, and you say like life is very good. But there were some problems, so you say like, hey, we will monitor it. We have some tools which can do all these things. There are some built-in Linux tools, for example, as well, which are still very good, and they will remain good forever. But you are very happy with the setup. But then the evolution comes of containerization, and Docker helped to identify the problems, especially on the resource user side. So nowadays, like everyone is using Docker containers to create like some sort of like an image or a stack, and it helps. It is very fast to build and deploy, and even if you are, especially if you're testing, then it's pretty cool like to have this in a single platform, right? And this was good, and then we have some more evolution, and the evolution was the name itself, the beast, Kubernetes, which is very fun or very time-consuming, depends how you like it. But it helps. It helps to definitely scale. It create the perfect concept of container orchestration. So then you have like, again, this is an example like how deployment looks like in Kubernetes. So you see like, okay, you can do things amazingly, but the complexity obviously adds there as well. You have to know the pods, services, deployment, namespaces, and so on. And it could be for a basic application or something more complicated as well. So the question is now like how you are observing your application today, right? You have scale it up because your audience or your user is growing. You say like, let's have more than one clusters, fine, all good. And if something bad happens, you always have this option that, okay, if something is not working, we can replace it. So you say like, hey, no problem. If that crashes or multiple nodes are crashing, we can create new ones because resources are getting cheap as well, and fine, that works. But things are still falling apart, and you're saying like, okay, the one which we created yesterday or a week ago it also crashed, and what you will do, right? So you are thinking and thinking, and obviously you can repeat the process again and again, but at the end your customers will suffer, and you also will suffer from that, right? And there will be a panic mode, a disaster mode, things will get fire or scary, and definitely you will be in the point where you feel like, okay, this is definitely not working and we need something which can help us to tell what's exactly going on behind the scenes, right? It's more important to see what's going in the back end. So what is the solution? So we talk about a little bit about the foundations of observability. So for me, it's basically, it's like this, that it's not a solution, it's basically our journey. So when you create some maybe containers or product for your customers on Linux or any other specific machine, you find out the issues, you see, okay, this is not working, you try to fix it, and then you move on, then you fix again if this is happening again. So it's like a cycle, and you find the root cause, you make sure that this does not happen again. So this helps you to understand, like, okay, this is what we are observing, and we have to keep doing it, and it's a cycle which helps to finally give you a refined image for your product, right? And there are three pillars of observability. So I think for everyone in the room probably knows that there's log files, right? Everyone check log files, sometimes maybe more frequent, more than a day, but there are times you have to check the log files because they give you the right information. If something crashes, there's out of memory or something, yeah. And then there is metrics. So metrics is basically, for example, how much the CPU is using. For example, the famous Linux stop command is basically telling you all about the resources uses or the metrics, like this is how much the RAM is using or the CPU is that much used and so on. And then there's also tracing. So tracing is basically a combination of logs and or advanced version of logs, because if something you call an application and you click on like get my data and it's trying to get your data, but there's a process in between which is taking time. So you can see the whole trace, like why it is taking so much time, and you can debug it. So now you know some foundations as well, but now the question is like, is there a complete open source observability stack? So there is at least one of many, but definitely I'm going to talk about Grafana, which is totally open source. How many of you uses Grafana? Maybe raise your hand. Okay, so for those who are new to Grafana, so Grafana is basically an open source monitoring and visualization tool. It is available on all platforms and also like you can run on Linux, Windows, even on Raspberry Pi to monitor your Raspberry Pi devices and so on. And it supports various built-in visualization. So the famous one is definitely the time series one. And also you can use like bar chart or table panel and so on. And the cool thing is that it is different from other data source monitoring tools, because then you have to configure something in the database and you have to make sure that it does not get changed, or you have to modify. Like there is always this danger point, but in Grafana you have to find, like identify the endpoint and tell like this is my source of data on this IP address and the port, and just monitoring it if you export the right credentials. So why Grafana, right? I mean, there are other monitoring tools as well. They're also good, but why specifically you might be interested in Grafana? So when I talk to people, like they don't know much about Grafana except that they see the screen which is in the middle, like, hey, this is pretty cool. I can observe this data of my application. But there is going a lot more. So we have a whole collection of the data sources. For example, we have a data source plugin for GitHub, for MySQL, for SAP, and so on. Like, I think we have more than 137, if I'm right, but probably more than 135. Maybe more, there are more, but anyways. And with these data sources, they might be running into your environment, right? And you say like, okay, now I have all the applications and I have the data sources. What can I use as a solution for open source part? So Grafana provides this complete open source stack. So L is for Loki, which is for log files, visualizing log files or log data. Grafana, the G is definitely the front-end visualization. Tempo is for tracing, if you want to check the traces and monitoring for that. Metrics or Mimir is for metrics. It can be also same as the concept as Prometheus, except that Prometheus has some limit in data retention. I think it's 14 days. Mimir provides more. And there's also one new, it's called profiling. Profiling is something like if you have an application and your customer says like, hey, we need this custom plugin or custom module. You build it, but it is not performing that well. So you want to see like maybe it's stuck somewhere in the loop. So profiling can give you the whole data in a more visualized format so that you can track out, okay, where it is stucking. And we have some more tools which probably you may or may not heard it of. So for load testing, we provide K6 as well. So for if you want to test load your application, we have K6 tool, which is actually, fun fact is that Grafana uses K6 as well when we make a new release. So we test our own tool using K6 because it's very good. We have also tools for front-end observability like Faro, eBPF, and Bela, yeah. We have tools for infrastructure and also for incident management, like if you are on alerting or on call. And with that, I will try to showcase a live demo. So this is probably my basic setup. I will not go in detail because this talk is more about to showcase you how this containerization works and how you can monitor your containers. So, but in simple, like I will be monitoring a WordPress application, which is very easy. But I have some tools in between, so I am checking log files via Loki, visualizing all the data via Grafana, and collecting the metrics. I will use Prometheus. And also I will be using Alloy. Alloy is basically a part of Loki. So Loki is the server, but Loki needs an agent, like someone who can ship those logs, so that will be Alloy. And in between, I'm also using some Prometheus exporters like MySQL exporters and PHP exporter to ship PHP metrics. And last but not least, I will be using cAdvisor to collect the container metrics itself, which is something important for this talk. And this is where you have to understand, because this also took me some time to understanding. When it comes to containers, especially when you're running Dockers, containers or for your application, normally people think like, hey, we can use Prometheus and it will give us all the metrics and data which we need. But you should not only just use Prometheus, you should definitely use cAdvisor, or it is called Container Advisor. It is created by Google some time ago now. It is a very stable product. And basically, it gives you more data for your containers, like the processes which are running, how much memory or disk space they're using. So it is only defined to collect the metrics for your containers, not for the whole node. While the Prometheus is actually for the node, like if you're running a virtual machine and then on that virtual machine you have containers, yeah, cAdvisor for the containers, but for the virtual machine you can use Prometheus or the node exporter, the one we say. So I will try to showcase the demo. So this is, So this is my Docker Compose file. Basically, everything is defined as minimum as possible. It is not like production type. It's more like for testing. But to show you, like I'm running Prometheus, Node Explorer, and then there is the part of cAdvisor where you have to define some volume points, which is defined in their documentation. And now already everything is running. I have my WordPress demo website is also up and running. So if I want to check the data for the dashboard, so I will go here in dashboards. And here is, for example, one of many panels which I'm just testing, but this one actually is much better. It's called cAdvisor. Now you can see the real-time data for all of your container deployments. So if we go down, we can see the CPU. We can also see the memory data as well. And you can create this dashboard manually or use the Grafana library created by the community. Like these dashboards are available on grafana.com/dashboard. I can just show you very quickly. And yeah, so you can find all these dashboard here as well. So this can save your time. But I want to show you something very cool feature which we just released in Grafana 12. So in Grafana 12, we have a new option. It's called drill down apps. Basically, we created a application to have all these metrics on the fly. You don't need to remember the Prometheus query to get that metrics in a or get that visualization. If you click on drill down and you have everything ready, you will see like these 4 options. So, but we are interested right now for the metrics. So if we click on metrics, we can already see all the data which our exporters are collecting via our configuration file. So the configuration file is the back part, but for the front end part, you don't need to think from scratch. You can get all this on the fly. And for example, if you are interested, like, hey, I am very interested in the memory part, you can, like for example, this one, select this one, and you can see like, hey, this is all the data we are getting. Again, it's not running for a while, so there is like no data in the past. And you can also get the breakdown and similar results. And if you want to say like, hey, this is the one I'm looking for, just click here and go in explore. Now the cool thing is that like, again, this one has a very basic query. So this is the query that is used to collect the average of container memory cache. You don't need to remember the Prometheus SQL because there are so many already. But with that, you can actually say like, hey, this is pretty cool. I want to create this dashboard. So you can just click on add and add a dashboard. And you can either create a new one or move it to an existing one. So this is a perfect way to save your time as a developer, and also can also save your time in knowing to debug your containers if you're running in your Linux environment. Okay, I will go back to the slides. I believe I dropped the clicker somewhere here, so I will stay here. So logs. Yeah, logs are, for me, is very important because I used to be working for customers who have like 20 GB of log files, and at least at that time, I didn't know about Grafana or any monitoring tools, so I use a lot of shell commands to identify, and there's always this point like, hey, we didn't do anything, but when we ask for a log, so there's always this like, well, you did something wrong, and we can identify with the logs. So logs definitely do not lie when it comes to like knowing what went wrong. And logs are important, and Grafana has this product called Grafana Loki, which is pretty cool because yeah, I found my clicker as well. So yeah, so basically here you can see that you have this log line, which is like telling about you have a timestamp, then your environment, maybe you're running an Nginx in an application environment, and then you have the log line like get or put, whatever. And the cool thing about Loki is that it does not index the whole log file. So if you index the whole log file, there are some tools which do, but I have seen the problem in real because then they run out of disk space or they took a lot of time to like to get it started. So disk space is also very critical because when you have an SLA or escalation, then you want to see debug the issues as soon as possible. And what Loki does this is only like do the indexing of the metadata. So it will do the timestamp and the label selectors. And with that, you can save a lot of disk space. So imagine the 10 TB of log file when you index it via low key, you have like, you do the 50 MB of indexing, and in total you have only 3 TB of data stored on your disk, while other tools may use the whole thing. And it does not take a lot of resources, so it is very resource friendly. And to do a quick demo for the logs. Yeah, so similarly, like we can view the log files as well. Again, if you have defined all the data correctly, you should see again this drill down apps in the logs, and you can see all the logs here in visualized format. Now this is pretty cool because imagine if you are running a lot of containers, you can do like Docker logs container name and you can get the data, but this is also pretty cool, like if you want to see the error or whatever, and you can create an alert for like if anything's come as an error. And let's take a look of, for example, this one. I really like this, this log file, so I say like show logs, and I have all the data, and I can also open it in explore mode, and this is the log line. So basically, again, just like Prometheus, the Loki also has its own query. So it's called logql, like promql is for Prometheus and logql is for Loki, and you don't need to memorize it again. We are trying to make it as more developer friendly as possible. All you need is like, okay, this is pretty much I look for. I can add it to a dashboard and start viewing my logs from there, and even can do the searching. So this is for the logs file. So incomplete, you can have this complete picture because due to time, I cannot show you the other two part, which is the profiling and tracing, but this is the whole cycle. Like if you have an application, you can definitely do the 3 pillars of observability, like log, metrics, and traces, and go beyond like profiling and load testing. And for that, there is a GitHub repository freely available for testing and playing around. You can take a screenshot of this one, definitely. I would recommend if you are interested. This has also very minimal requirement, like you just need like a Docker and play it, and there is also built-in Grafana configuration file, so you just need to open it in your browser on port 3000, and that's pretty much it. My final takeaways will be that it is definitely very OSS friendly and available in many flavors. Again, I work a lot, especially with the community, and they have different sorts of requirements. So Grafana helps in that way if you are using different flavors of operating system. Yeah, the second is definitely the rich features and community support. So we have come bring all this feature and also still creating new features with the help of the community, because community, I think, is the backbone here. We get a lot of features, requests, and bug fixes, and we do. And I think same goes for Linux users, like Unix users have like specific requirements or help us to understand or troubleshoot many issues. So community is definitely the win part here. It brings a lot of improvements. And the most important is that it is a completely open source solution. So you are not bound to use any commercial product. If you're looking for like an open source solution which simply works on your operating system, I think this is definitely the right way to go, because you're not just getting one component of like, hey, I can just visualize the logs or metrics in Grafana, but you're getting like logs, metric traces, and even profiling and load testing. So yeah, I would recommend that if you are new to Grafana, join our GitHub Grafana repo if you want to report issues or feature requests. The Slack channels is very active. We have like many contributors who are helping users if they have questions, and also I myself also stuck on community forums. So community forum is like a very good learning if you want to learn about Grafana or get tutorials and so on. And you can scan this QR code because all the documentation also available on, I have like created like a GitHub README page where it lists like what kind of documentation and links to GitHub repos which I have used. So yeah, that's pretty much it for my presentation, and happy to answer any questions now. Questions?
Something within Loki that would allow you to have a dashboards concept for log ingestion? So you could say, this is a MySQL server, parse the MySQL logs, rather than I'm going to spend 2 weeks handwriting a query to parse individual kinds of logs. That's kind of the feature that I feel like is missing from a lot of the log programs.
Yeah, the question is like, do Loki have like a feature which is specific to the application that you were trying to view the log file, like MySQL? That's a good feature request actually, because currently what we are doing is that we have at least come in this way that instead of writing the whole query manually, we have this drill down app which can show you the logs like generated in a time series or bar charts in advance, and it can identify the text like is it an error level, info, or WAN. For filtering, yeah, there is involvement of like what application you're using, and then you may have to put this. This is currently not yet done, but it's definitely a good feature request for future to have application-based log filtering design for like on the fly for the users. So yeah, thank you. Any other questions? Yeah.
Can you talk more about indexing, please?
I cannot talk, I'm not that super expert, but I can try to explain in a way. So for example, before Loki, I used to work with a tool called Splunk. And what Splunk does is that we have like a log file from our cloud servers, and index everything. So basically, indexing means like if it is doing the full indexing and you search for the log line which says like, I'm a bad person, as an example. If you type that, it will, because it is indexed, it will come in the search result. However, in the Loki part, we are indexing the timestamp and the metadata. So you are more relying like, hey, at this time, what happened? You define the time range and then define the context, what you are looking for. Then it will do that. So it saves the time, this storage in that way. That all I know in detail, because indexing in Loki, it's more on very, very, very different talk on the architecture level.
Can you save space?
Yes, you can, because it does not index the whole log file. So it indexes, as shown, I think, in the picture. No, all good. Then I will just speak. Yeah, it does not index the whole log line. It does index the metadata. So with that, you can save a lot of time. The problem which I used to had is that when I was also working as a support, like on call, and if the tool which is indexing the whole log file, and you say like, hey, I need to check the log files right now, the tool is either broken because the disk space on that virtual machine where you have deployed is already run out of it, and it needs time to set it up, resync, and so on. And with Loki, it is kind of efficient because you don't run out of disk space. There might be some saying like it is a little bit like fraction of a second slower, but in my opinion, this does not like make much like decision making, because at the end, like you just need to view the log file, whether it is like a fraction of a second late or before. At least it is present there. So yeah.